All right. So this is now beginning to spread some moisture up and over the top of this thing. So I think we had some audio trouble at the beginning of this, but we're all good now. To sort of recap, since the audio wasn't working, we're at a point now where we lay out general ideas. If you're looking for who gets what and when, we can't give you that yet. No one can. No model, no groundhog, no farmer's almanac, no meteorologist can tell you who gets what and when for a winter storm in the southeast 5 days out. The best we can do is lay out some ideas. And the general players are on the field here. We've got a big, deep Arctic high pressure up here. You've got a cutoff low here. So that to create a winter storm, you need moisture, cold, and lift. We know we'll have moisture. We know we'll have cold. We'll know we'll have lift. So that's why we started banging the drum on this a couple of days ago that, hey, yeah, the players are all there, but how do they come together? That's the part of this where it's a little trickier than meets the eye. Okay, so Friday night, you start to get a lot of overrunning. So again, that is warm, moist air riding up and over the top of cold Arctic air in place. So you start to see snow and ice break out across Kansas, Missouri, Arkansas, Oklahoma, and Texas. Then that spreads into Louisiana and Mississippi. This is now at noon Saturday. And look at that. You've got a 1043 Arctic high over Iowa. And you've got a developing surface low down here over northern Mexico. And you've got all sorts of trouble between those two, with a lot of Arctic air and a lot of freezing rain, sleet, and snow overspreading most of the southern plains. This would be lunchtime Saturday. Again, this is all off of the European computer model run from this morning. Let's fast forward now. Here is Saturday evening. We're now at 6 o'clock, Saturday evening. At this point, it is snowing hard on the entire state of Tennessee. A crippling ice storm is in progress across northeast Texas, Louisiana, southern Arkansas, back down into central and northern Mississippi and north Alabama. Then, fast forward a few more hours. We're now at midnight Saturday night. A couple of things I notice on the European that are different. So you've got this Arctic high, kind of double coverage here, beginning to take shape over New England. That's starting to wedge some colder air down into East Alabama. So the Euro starts to actually spread the threat of ice down into some of our counties in the southern half of the state Saturday night into Sunday morning, specifically northeast of Montgomery. I'm talking Coosa, Tallapoosa, Chambers, and maybe Lee. This would be Saturday night. For the rest of us, it's a cold soaking rain. So this is now sunrise on Sunday morning. And what I'll do here, we'll go out and I want to pop you into the regional view just so we can get a little clearer picture of what's happening in this exact time frame. So we'll go back again to Sunday morning. That's sort of the... So now you've got fairly significant freezing rain across parts of Macon, Tallapoosa, Chambers, Lee, northern Russell, with a cold soaking rain, and I do mean cold soaking rain south of there. You've got a crippling ice storm ongoing across North Georgia, up through the Carolinas, and then heavy, heavy snow on the north side of this. Then it kicks out, right? So that's the European idea. European idea is major freezing rain and sleet essentially north of I-20 Saturday night, and then right as this thing departs, enough cold air wedges in from Georgia to get us some freezing rain in the far eastern sections of Alabama. Is that right? Is that wrong? It's an idea, right? This is the American long-range computer model. And I'll pop in again. Let's go to the regional view where we're able to really kind of zero in on what it's showing. And please understand when you're looking at this, this is all going to change. What we're laying out here are model ideas, and then I'm going to go over what I think is going to actually end up happening here. But all of this needs to be kind of couched around the idea that these details are going to change. The only thing anyone can tell you right now is that there's going to be a winter storm somewhere in the southeastern quarter of the country Friday through Sunday. Is it Alabama, Georgia, Mississippi? Is it Arkansas, Tennessee, and the Carolinas? No one knows yet. My answer is probably all of the above. This is going to be a big storm. And I do want to lay this out right now. This is going to be bigger than what happened on Saturday night. Saturday night, we had snow that fell into an environment where the ground temperatures were very warm. We had temperatures right around 31, 32, 33. The sun came up immediately after that and melted almost all of it within a few hours. This next one is not going to be like that. This next one is going to be a far more impactful scenario with the possibility of freezing rain, which is just ice, across a big part of Alabama. So let's walk you through the American long-range model idea. So nuisance rain Thursday night, nothing big there, no severe weather. It's warm enough for just liquid here. Then you get to Friday afternoon, and we start to see freezing rain and sleet break out across southern Arkansas, northern Louisiana, and the Mississippi Delta as Arctic air drains in from the north. We get a little bit of sleet and freezing rain kind of on the bottom end of that first little initial wave. And let me say this, too, for Friday night. A lot of times computer models underestimate overrunning events. They're too slow and they're too weak with the amount of moisture involved. So it is entirely possible if the American scenario is right, and this is really more overrunning than driven by surface low. Because that's one thing I'll point out in a moment. That's a big difference between the two setups. The American computer model doesn't really ever develop a strong surface reflection of low pressure, at least not nearly as early as the European does, and that has some big implications downstream. It's really driven more by pure overrunning. Southwesterly flow aloft, moisture coming in up and over the top of cold air getting replenished from the north. So Friday night, if the American model is right, I suspect we could have issues, particularly north of Clanton in Alabama, Friday night. Then Saturday, those issues become a little more widespread. And you'll notice, again, because there is not as strong of a surface low pressure, you get a stronger northerly surface wind, and you get more freezing rain. So this would be at sunrise Saturday now. You've got freezing rain and sleet in places like Tuscaloosa and Birmingham and Anniston and Gadsden and Coleman. It's snowing from Muscle Shoals to Huntsville over to Scottsboro and Fort Payne. There's heavy snow falling up in North Georgia. Then by lunchtime Saturday, we now have the world's worst type of precipitation falling across west and southwest Alabama. I'm talking freezing rain. That is rain that falls as a supercooled water droplet. And then as soon as that droplet hits something that is not above 32 degrees, it freezes onto it. Bridges, overpasses, power lines, blades of grass, tree limbs. This gets ugly quick. This would be Saturday afternoon in places like Camden and Demopolis and Marion and Clanton and Rockford. This is 3 o'clock Saturday, same thing. You'll notice for Montgomery, east and south, this is just rain. North of Montgomery, even now into parts of Autauga and Coosa and Tallapoosa, you now have freezing rain ongoing. Then that dips south. As we get into the overnight hours Saturday night, a lot of this begins to dip down into South Alabama. But notice on the American model, you really don't see a strong closed off surface low pressure with this until we get to 6 o'clock Saturday night. The European does it much earlier, which means a stronger warm nose, which means stronger wedging, because that surface area of low pressure on the Euro is back here. And it actually pulls in that pressure gradient, pulls in more wedging. So from the American long-range model, the best chance of icing in our area would be north and west of Montgomery. With the American with the American model, the best chance of freezing rain is north and west of Montgomery. With the European, it's probably east of Montgomery. So a lot lies on exactly when that surface low begins to form down in the Gulf. Does it form in the Gulf like the European says and come on up through South Alabama? If so, it's mainly rain for a lot of us with some ice problems in the far eastern counties. Or does it wait until it reaches the Florida Peninsula or even the western Atlantic Ocean to get going? That will be critical in this, and the answer is right now no one knows. There's not a computer that you can say, oh yeah, that one's got it right. It doesn't work that way at this range. Okay, onward with the American solution. By Saturday night and into Sunday, you've got leftover freezing rain and sleet in South Alabama, but a lot of this is done. I'm not really even going to show you the amounts on all of this because, frankly, they're sort of crazy with the ice. And I just don't have enough confidence in them yet to put them out there. But I do want to just, wherever there is enough cold air, there's going to be a lot of moisture. So wherever the temperature drops to 32 degrees or lower, there's going to be significant accumulation of ice and snow. History and pattern recognition tells me that's probably over the northern half to 2/3 of Alabama. I don't see a lot of data for this being something that brings snow and ice south of way in South Alabama like this last one. I think parts of Southwest Alabama could be in play if the GFS is right, if the American model is right, and you end up with a weaker surface low and you end up with stronger cold air advection in the low levels. Then I think this could be an ice situation. And a lot of that, the terrain comes into play here. You get a lot of cold air drainage over there in West and Southwest Alabama down the river bottoms, right? We've seen it in a lot of previous winter storms where Camden and Monroeville and Demopolis and Linden are 29 or 30 degrees, and Montgomery and Union Springs and Troy are more like 35, 36 with just a cold rain. We see that a good bit. So those are the two main scenarios. So now the other thing I want to show you here is the Ensemble data. This has my eye as well. And also, let's do this first. The New European is getting really close to seeing this whole thing. This would be a brand new run. You haven't seen this yet. Neither have I. Neither is the rest of the world. This is all coming out right now. This is the brand new run of the European computer. And again, you'll notice with it, Friday night, it's slower. That's the first thing I noticed. But with these overrunning setups, a lot of times they start fast. So Friday night, I think that's a real, you better watch that. North Mississippi especially, but even into parts of West and Northwest Alabama. Then by sunrise Saturday morning, which is almost as far as we go out yet with this, you've got a crippling freezing rain event ongoing for Northeast Texas, North Louisiana, Southern Arkansas. Again, freezing rain is rain that falls as a liquid drop, but the air temperature is below 32. So as soon as it hits something that's elevated above a warm ground, it freezes on contact. Mailboxes, your deck, bridges, overpasses, power lines, tree limbs. And if the ground temperature itself goes below 32, then freezing rain does begin to accumulate on the actual ground itself, but that takes longer and it takes a colder regime in place here. Then we'll go out to Saturday at lunchtime. You've got rain. Looks like this may be a tick warmer at the onset here, but let's do this. I like to do this on occasion. Check the model trend on this, right? So what this is showing, this is the last several runs of, these are the last several runs of the European model. We'll skip forward here. Oh, look at there, we're out now. So I want to do the model trend thing in a moment. We just got some new frames. Let's look at those first. Okay, so this is now Saturday at lunchtime. This would be Saturday afternoon, Saturday evening, Saturday at 9 p.m. So see what I mean? You've got this much stronger surface reflection out here in the northwestern Gulf. That's moving a lot more warm air aloft. And warm here is a relative term. I just mean above freezing, up into central Mississippi and central Alabama. So if this European idea is right, a lot of what falls in the middle of the state initially is going to be rain, and then it ends as freezing rain as a wedge of colder air begins to slide in from Georgia early Sunday morning, which we'll see in the next few frames here. The 18Z European only goes out 144 hours, but we're really close on that. We're at 129 now. While we're waiting on new frames to load, let's do this, that model trend analysis I like to do. There's the 132, we'll do that. So this will show us what the European has looked like the last several runs here. And so this was the run yesterday morning, 12Z, 0Z. Next run, this is last night. Morning run, afternoon run. So these are very similar. The last two runs there, if anything, it might be a tick warmer, right? You've got a little less freezing rain up around parts of Tuscaloosa and Jefferson counties. In the new run, this is the new run. It looks like surface temperatures are a little warmer, but warm here is, again, a relative term. We can look at the forecast sounding out here, and this is in Marengo County. You're at 41 degrees. It's a cold soaking rain, big warm nose aloft. So that's what's kind of saving the day from ice on the European idea for some of us, is this idea of a surface low going down here close to New Orleans and back into the northwestern Gulf, and that then moves some warm air up and above all that. So let's go to the brand. This is again the newest frame here. This is now at 3 o'clock Sunday morning. You've got really heavy freezing rain up at Birmingham. Look at this. Yeah, this would be nasty stuff. 31 degrees. Your bridges and overpasses, RIP, those are going to ice over if that's right. And pretty heavy precip as well. You've got a closed off surface low now close to the Alabama-Mississippi border down near Mobile. You've got cold air wedging in from Georgia at the same time. This is a pretty classic East Alabama ice storm look. And sure enough, yeah, let's look at the forecast sounding. This is 3 o'clock Sunday morning in Tallapoosa County. You're 31. Huge warm nose right here. See how that green line bends over like that? That's warm air. When it bends to the right, that's warmer air. And you're below freezing at the surface, but 2,000, 3,000, 4,000 feet above the ground, the temperature is extremely warm. I'm talking close to 50 degrees Fahrenheit. So what's happening here physically, snowflakes are forming up here between minus 12 and minus 20 degrees Celsius. So right up here, saturated, cold enough, snowflakes are forming. They're falling down, 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 down. Then the air temperature goes above freezing and those snowflakes melt. They form into what's called supercooled water. They keep falling, they keep falling, they keep falling. And then the layer very near the ground goes back below freezing. So for freezing rain, you need cold air, warm air, cold air. If you think of it like a layered cake. A lot of my analogies go back to food. Sorry. So this would be a pretty substantial ice situation in northern Chilton, northern Tallapoosa, Coosa, Chambers. And then the newest couple of frames here we'll get in. This is now Sunday morning, still major ice storm ongoing in East Alabama. It's cold rain for most of the rest of us. This is 15. This is now 9 o'clock Sunday morning. And it's, look, a lot of Alabama's changed to rain because you've got this strong surface low down here. And as a result, you've got a ton of low-level warm air advection, either near the ground or above it. And a lot of this is now rain, right? And then this is Sunday afternoon. It's still just rain across most of Alabama. You've got ice ongoing in North Georgia. And this is a whopper of a snowstorm for Tennessee. So that's the European idea, and we actually were able to go over it live, the kind of the brand new European idea. And I'll point out too. I'll go back. Let me go back to Sunday morning at 12Z. So this is the new run. That's the old run. The old run had ice getting into more of Macon, Russell, and Lee. The new run says no, just a cold rain. But I'll tell you, it's going to be close. I mean, that forecast sounding I just clicked was in Lee County, and it's right around 32 degrees. So, again, just ideas here. The American long-range model has less surface reflection, and as a result, less warm air advection. And the American long-range model would be a more substantial ice event for most of central Alabama with snow in the northern sections of the state. The European model develops a surface low about 12 hours faster back over the northern Gulf and moves it across South Alabama. If that were to verify, this will be rain that then shifts over to freezing rain in far east Alabama. I'm talking again, Coosa, Tallapoosa, Chambers, maybe Lee, maybe Macon, maybe Russell, and then changes over to rain before ending. It would be a lower impact deal for us with much higher impacts over North Alabama, Georgia, Tennessee, and the Carolinas. So we don't know yet which one of those ideas is correct. One thing that we use to try to figure that out is something called the ensembles. The American long-range ensembles are out already, so I'll share those with you now-ish, because they're actually trending a little colder. Again, it all goes back to the difference in the setup. The Euro gets that surface low going in the Gulf, which pushes warm air in the low levels up through Alabama, and you end up with this kind of icy, rainy mess with higher impacts in East Alabama than the rest of us. The American long-range model doesn't develop that in time, and you end up with it's a lot more just overrunning. And as a result, you get a kind of a different idea entirely. Again, let me show you this. This is that European, or this is the ensemble. So what we're doing here, we're taking the American model and tweaking a few things with it and rerunning it. And then we tweak a different thing and run it again. And then you tweak another thing and you run it again. And you end up with, dozens of different ideas. Think of this as the choir. The thing I just showed you before this was the what's called the deterministic run. That's a soloist. That's a person who stands up in church and sings by themselves. This is the choir. So let me show you this idea with respect to snow. So this goes out, we'll stop it here Sunday evening. And if you average all of these together, you actually end up with a couple of inches of snow in North Alabama, and I would imagine a good bit of ice, and then a whopper of a snowstorm up in Tennessee. Now remember, we're averaging together a whole lot of ideas here. So there's some of these choir members are singing ice, and some of them are singing snow, and some of them are singing rain. But when we average them all together, what do we end up getting? Well, ice going to snow in North Alabama, and probably these ensembles would be a lot more of a freezing rain event for a lot of the central counties of the state. But one thing I do want to share with you is this. So I noticed this little trend earlier. This is the GFS ensemble look. So again, this is the choir. Think of this is just the choir. But what I want to show you here is the last 4, 5, 6 runs of this thing. This was yesterday afternoon's run. Notice where the snow is, right? It's up in Tennessee. Okay, let's go forward. Okay, now the snow's in North Alabama. This is the next run. This is the evening run. This is the midnight run. This is the morning run, and this is the afternoon run. So notice the slow evolution here. There's a southward push with who gets snow on the American ensemble. So you really do have kind of a model face-off happening right now. The American modeling, pretty convinced this is purely an overrunning setup for Alabama. The surface low doesn't form until it passes us. The European model is more convinced that there is a surface low that gets going down in the northern Gulf and pushes a lot of warm air up in the middle of the state, and this is mainly cold rain for us. Both ideas are completely possible. I have seen both ideas. There's not one that really stands out as more accurate than the other. So what's a girl to do? In this case, girl meaning meteorologist. Well, we need to wait and see. We need to get better data. And I know that's not the bold answer, but it is the honest answer. We need to wait and see. We need to see what eventually these computers will start to converge on an idea. And when we start to see that agreement between the two camps, that's when we'll start to be able to know how this plays out. When you are forecasting a high impact event like this in the mid-range, there are 2 key concepts: consistency and agreement. Consistency, and I'm going to simplify this, is that specific computer model that we get multiple times per day, is it agreeing with itself run after run after run after run? Meaning, does the American model seeing the same thing with each run that we get? That's consistency. Right now we have that. The American model is consistently agreeing with itself. The European model is consistently agreeing with itself on its scenario. Then we look for agreement. That's the second big thing, is agreement. Do we have agreement? Does the European idea agree with the American idea? And right now the answer is no. Now, from a broad perspective, they're actually pretty close, right? You've got cold air, you've got moisture, you've got all the ingredients. They're both showing a big winter storm in the deep south. But I'm talking specifically about that surface low forming in the northern Gulf. That's the keystone to this whole forecast. And on that specific point, we do not yet have that agreement between the American model and the European model. So the prudent thing to do is wait until you have both consistency and agreement. Right now we have consistency. We have agreement in most of the large-scale setup, but we don't have agreement on that one key idea. Is there a surface low that forms with this thing? And if so, exactly when, where, and how strong? Once we see that, we'll know a lot more. So that's the nuts and bolts of this thing. We've gone 30 minutes, which is probably 30 minutes too long, but with the audio hiccup at the beginning, I wanted to try to make it up to you. So I'm going to wind this thing down. Big reason I did this, there's no WSFA 12 news at 4, 5, and 6 this evening because of basketball. So I thought, why not get everybody together and talk about the weather? What a great thing to talk about, right? Right. So that's what I did. I will keep looking. You know, the fun thing about I'm obsessed with the weather. I think it's fascinating. I will be looking at weather stuff all day and all night. That's what I do. And before we go, hey, don't click X just yet. I need to say this first. I want to give you another first alert here. So whatever happens this weekend, there's really outstanding consistency and agreement in the computer modeling, in the teleconnections, in every piece of data we see, pattern recognition, all of it, that we are going to turn much colder, probably even colder than this weekend, out towards the end of the month. I'm talking Thursday, January 29th, Friday the 30th, and into the first few days of February. And there is also a persistent signal in there for another threat of snow or ice somewhere in the deep south. So again, we've got to get this weekend one through first, but I do want to at least put it in the back of your mind that we may end up dealing with an additional shot of very cold air and possibly more wintry weather issues in about 10 days' time, out towards the 29th of January. There is no one on planet Earth, no meteorologist, computer model, groundhog, or farmer's almanac can tell you if that's going to pan out. But the consistency and agreement on that is actually pretty good that it's going to turn colder again at the end of the month. So I wanted to plant that in your ear before I let you go. So there you have it. When it comes to this weekend, when you're looking at computers, if you are, watch for when and where and how strong that surface low forms. That's going to drive this whole thing. All the other features are there. They're in the right spots. But that surface low, if it forms and comes up through Alabama, then this ends up being a cold rain, perhaps a brief window of freezing rain in the eastern counties, but it's mainly cold rain. If the American modeling is the right idea and that surface low doesn't form until this is past us and you get mainly an overrunning setup, then this is a much more impactful winter weather event for us here in Alabama. So there you have it. Hope this has been informative. As always, hope you all have a great rest of your Monday evening. I'm going to go work on dinner. I think we're doing leftovers tonight. Leftovers and then the national championship game. No SEC teams, man. What are we doing? Indiana and the Ute. How about that? Mendoza versus Carson Beck. So, yeah. Anyway. All right, everybody.